This is part 6, the last, of building the acoustic guitar from the ground up. Today, it's final assembly with setup, and one of my favorite parts, testing and trimming the final sound using a bit of technology. First, I want a strap button for the neck bolt. Now, to locate proper bridge placement, I'm going to use this jig that registers on the 1st and 12th frets. For structural integrity against string tension, the wings of the bridge overlap the X-brace on the underside of the top, and bridge pins and screws with T-nuts holding the bridge pierce the double-layer hardwood bridge plate. T-nuts are glued in and bridge is on. Ream pin string holes and cut string grooves. And now for the setup. With the bone saddle cut and shaped and in place, the strings are placed and tensioned. The truss rod is tightened for correct string relief, and the string grooves in the nut are filed to just the right depth. Proper string action, which is the height of the strings above the 12th fret, is critical for ease of playing. This one's a little low at 1.5 millimeters, should be 2.5. It's easily adjusted with the neck adjustment screw here, which fine-tunes the tilt of the neck. There's 2.5 millimeters on the bass side and 2 millimeters on the treble side, which is target, so the neck set is proper. As you can see, I darkened the brass nut with the gun blue. I use a compensated nut, which has a slightly different distance from nut to 1st fret for each string. This corrects the pitch for the increased string tension caused by fretting the note with your finger. I also use a fully compensated saddle for correct overall string length. Again, for best intonation. Now the guitar is ready to play. But with the handcrafted process, I have the luxury of modifying the tone of each guitar individually by trimming the inside braces and weighting. A quote from one of history's famous guitar makers comes to mind. "Every guitar I make is my very best, right up until I put the strings on." Time for a first audio test. In this sound-damped corner, the guitar is suspended by the neck, so it vibrates freely. Strings are tuned and damped. A microphone a meter above is connected to the laptop, where software performs a fast Fourier transform of the guitar's frequency response. A kind of audio fingerprint, if you will. I just tap with this rubber mallet. Here's what the microphone heard. Frequency from 0 to 1,000 hertz versus amplitude. This is the body air resonance at 91 hertz, the main top resonance at 173 hertz, the live back resonating and driving the top at 221 hertz, and the diagonal dipole top resonance at 342 hertz. I'm going to focus on these four main peaks here. The goal is to fine-tune these peaks to target frequencies midway between notes on the musical scale to smooth the guitar's sound. I'm going to confirm the peak at 342 hertz as the diagonal dipole by sprinkling these Italian herbs on the top and driving the top at 342 hertz to observe the pattern. You see how the herbs migrate to the node lines. So the top vibrates like this, with the node line between the two here. This is basically the cross-dipole mode, forced to a diagonal pattern by the asymmetrical braces on the underside of the top, which I call tone bars. This is an important characteristic of the X-braced guitar sound. Going in through the access door, I'm going to carve the central back brace with this violin maker's plane to loosen the back and lower the 221 Hz resonance, which right now is dangerously close to A220. This should also lower the air resonance just a little toward my target of 90 Hz and lower the main top resonance toward my target of 170 Hz. After shaving 2 millimeters off the center of the back brace, the air resonance is now 90 Hz, top monopole resonance 168, and the live back peak is at 216 Hz. Diagonal dipole 341. The relative heights of the peaks look good to me based on experience, so I think we're good to go at this point. Of course, while I find this testing to be enlightening in linking the wood geometry to the performance of the instrument and the actual sound of the guitar, it is far from the only means to achieve beautiful guitar sound. Great design, top quality materials, and skilled implementation are critical. And now it's time for the most important test, the listening test.